Good evening. Welcome in MA Philosophy MP MPYE-001, block number 4, unit number 5, applications of symbolic logic. Objectives. This unit is to limelight the application of symbolic logic in modern era. The instrumental value of logic is well known in many disciplines such as philosophy, mathematics, and computer science. Mathematics teaches logic almost as an extension of algebra or calculus with lemmas and proofs, and also computer science teaches it with more emphasis on its applicability of for enriching programming power or for building thinking machines. But philosophy, of which logic has always been a fundamental part, approaches logic somewhat differently. For then, its key concerns are different kinds. We present a range of binary systems suitable for representing information in digital components. The binary number system is explained, and binary codes are illustrated to show the representation of decimal and alphanumeric information. We introduce the concepts of Boolean algebra from a fundamental point of view, correlating with symbolic logic. The correlation between a Boolean expression and its equivalent interconnection of gates is emphasized. At present, in the field of communication, entertainment, medical electronics, and digital electronics has taken giant strides. Here, fundamental ideas about implementing a logic circuit for a logic expression or writing a logic expression for a given logic circuit are discussed. All possible logic operations for two variables are investigated, and from that the most useful logic gates are derived. The characteristics of digital gates available in integrated circuits form are presented. This unit supplies the diagram and tabulation method for simplifying Boolean functions. The diagram is used to simplify digital circuits constructed with AND or NAND or NOR and wired logic gates. The chief endeavor of this chapter is to utter that the digital logic is not based on members, but they are based on the sentences. More specifically, it is based on the connectivity of the propositions. Primary purpose of this unit is to facilitate education in the increasingly important areas of multi-value logic suitable for representing information is fuzzy logic. The role of symbolic logic is decorated in the multi-value logic. Truth status for proposition is challenging and is not restricting the future events. The fundamental of fuzzy propositions is also discussed in this chapter. Introduction. In the history of Western logic, symbolic logic is a relatively recent development. It is the study of human thought through symbols. It is learning towards mathematics and symbolization. It would be a high hopeless task to discuss modern considerations of logic by the use of openly ordinary language. A symbolic language has become necessary in order to achieve the required exact scientific treatment of the subject. Because of the presence of such symbolism, the resulting treatment is known as symbolic logic. Application of symbolic logic with digital logic. The word digit is resonant from the Latin term digitus, which means finger or two. The fact that this system has 10 digits is commonly attributed to the 10 fingers of a human being. The most commonly used number system is the decimal number system. It is composed of digits 0 to 9. Digital logic is concerned with the interconnection among digit components and modulus. Digital computer has made possible many scientific, industrial, and commercial advances that would not be attainable otherwise. Our space program would have been unfeasible without real-time, continuous computer monitoring, and many business enterprises functions efficiently only with the aid of automatic data processing. Computers are used in scientific calculations, commercial and business data processing, air traffic control, space guidance and educational field, and many other areas. A digital computer is a programmable machine that processes binary data which is represented by binary number system. The simplest number system employing positional notation is the binary system. A binary number system uses only two symbols or digits, namely 0 and 1. They are the binary number system which has a base or radix of 2. A binary digit 0 and 1 are called bits. 4-bit binary used in called nibble, and 8-bit binary used is called byte. This unit is also much more symbolic and practical base. We can discuss this further in class. You can see or read this in IGNU e-content app. Thank you.